Means those are plan to PhD or MCA having one research paper. Typically in our organization having one research paper in master organization. That means MCA. So it is beneficial for them. And any doubt, all our students. So any doubt in any point, you just ask me immediately. Don't hesitate for that. Okay. So specifically, I am going to discuss the what is an image. All of you know the numerical data. That means 1, 2, 3, 4, 2.3, whatever the numerical data. But you don't know about the image. You know the image. You can identify me. It is an image. It is an image. But how the system can identify the image? That is a very difficult task. So it is a complex work. So typically, how to understand the image first. Which type of information placed outside inside the image? That is a very important. You can identify easily the image, but the system can identify how. So for that, there is so many techniques. We discuss one by one. So medical imaging is a pivotal component of modern diagnostic medicine, enabling clinicians to visualize internal structure and functions of the human body non-invasively. Non-invasively means what? You take the blood, you conduct your blood type, O positive, A positive, whatever. But take the blood sample first. But what about the image? It is a non-invasive. That means without painful, without surgery. So you can take the image. If you feel suppose you feel the headache from the period of time in your brain, you take the image first. That is the first one. You take the image. For what purpose? Any abnormal things occurs inside the image, inside the brain. For that you can see by using what the image, different modalities of the image. So here it refers to the technique that do not require surgery and cutting the skin or inserting instrument into the body. Suppose you take the blood, you put the needle inside your finger, so it is a painful task. But the image is the non-surgery. That means without surgery you can take the image. So manual, different techniques or the modalities are there. So having so many computer-related talk or medical talk, that means the modality. Modality means what? Different techniques in which you will take the image. So here, manual analysis of image is time consuming and subject to human error also and limited to inter-observer variability. So why we use the nowadays the computer? Why use the AI? Because in absence of manual or in absence of human being, you can or the system can identify the error easily in very less period of time. So here we focus to the AI or focus to the machine learning cluster. So this is the step 4. This is the important one. I am highlighted over here. Manual analysis of the image is time consuming. That's why we prefer to the machine learning or any image processing technique. All of you clear? So this is our object. So imaging modalities, here again, I am highlighting over here. What are the objective or the outcome of that lecture? Imaging modalities are different methods, or you can say technique, used to create a visual representation of the interior of the body for medical analysis and diagnosis. Now, comes to the machine learning. Why use the machine learning? Because you use the machine learning. By using the machine learning, you identify the problem in your image gene. That's why we are using the machine learning or deep learning technique. Machine learning means feature abstraction. You have to use some algorithm of that. But in deep learning, you use that one by using the machine. That means automatically extract the features from your image. So here, now, start to understand the image processing. What is an image? So generally, we are using, have you seen the MRI image? It is in which one? X-ray image, MRI image. It is in which one? Image how it is visible? By using what? It is a grayscale image, black and white. So this is the grayscale image. So first you understand the image. Here, a digital image is a 2D function. Image is nothing than it is a matrix. You know what is matrix? Row and column. In the graphical manner or in the computer talk, another higher form or 3D, 4D form, you can convert it to 2D image. For easy computation, you need for storage the space maximum. You use the 3D image or color image and use the 2D image, which requires more memory space. Obviously, the color image requires more memory space. So, from the space point of view, you are use the 2D image. Another thing was computation. You can easily calculate or process your image by using the i5 processor. But it will be difficult the color image for accessing or the processing the color image will be difficult in i5. We need the i7 because during I have faced that problem. My image was the length is that means matrix the row is 1025 and height width is 1025. That means small. That means size is very large. So it will be very difficult to execute that image in our i5. That's why we need some what cloud computing technique or cloud space. We need some cloud. Or you can easily i7 because at that time it was not there. That means i7 processor is very costly at that time. That means in 2017-18. So that's why we need the high performance computing lab for that for accessing that image. So it will be better always convert your image into 2D. So image is what? It is a function f of x, comma y. X coordinate, y coordinate. This is the function. And each matrix, that means what? Pixel, each row. Getting my point? Yes, ma'am. Suppose row, you find out the particular location. That means ith row, jth column, you move to that particular location. You find what? The intensity value. This is the image value. You know the size. Suppose your image size is 25 into 25. That means 25 row, 25 columns. But if you identify the specific information of that particular cell, that means to access the information, you put the value I10, then that is row 10 or column 50. Whatever. You put the value, accordingly access the information from that location. This is the image intensity value. Intensity matlab that information stored over there. So specifically, we are using the black and white image, or you can say binary image, or grayscale image. So binary image, that value is range is 0 to 1. Remember that. Black and white means 0 is black, 1 is white. So only two values. Someone asking to you what is binary image? That means only two values are there, 0 and 1, nothing than that. So this is a black and white image. Either you can find out the cell is total black or total white. That is the 0 and 1. But if someone asking your image is grayscale image, that means what? It is a 8-bit image. 8-bit मतलब क्या है? 2 to the power 8. 2 to the power 8 means if I'm starting 0, that means 0 to 255. All of you agree with me or no? 2 to the power 8 means what? 0 to 255. Or if I'm using the value from 1, that is 1 to 256. That means what? Each pixel value. Suppose I am asking what is the value of the specific location I10, then j equal to 50. You put that value in the coding, you access that information, automatically extract that specific location. Value. Yes or no? That is the intensity value. So range is what? 0 to 255. That means what? If we found the black, that means 0, then height, that means more circle to the 255. So this is the grayscale image. So in our MRI image or what? Mammogram image or any image, you can easily identify by using the grayscale image. Always it is better to convert your image to the grayscale. First, for easy computation, easy calculation, easy storage. Less memory space it will require, and within less period of time it will display the value. Clear? So how you can compute the value for the image? Suppose you execute the PNG image, .png, or any color image. What is the execution time? Suppose any image. Suppose you take your image. Your image. You take simply your image. You convert it into image is colorful, then convert it to grayscale. You find out the computation time. point of view, it will take more time. That's why it will better to convert into 2D image. And the 2D image is always the range is what? 0 to 250 height. And 2 to the power 8. It is a 8-bit image. So similarly, just tell me, what is the RGB image? Means colorful image or color image? Red, green, blue. Then each pixel will contain how many channels? 3 channels. Each pixel contains the 3 channels. That means what? Red, green, blue. 2 to the power 8 to the power 3. 2 to the power 8. 12 to the power 3. Because each cell should contain red, green, blue. Getting my point? So it will be very difficult for computation. That's why we are using the grayscale image. It will be better. You will use the colorful image or color image. Doesn't matter. But for the if you have that high performance computing lab or IC processor, you can easily access that one. But if not, your system will be high. Yes or no? So it is better to convert that to image. All of you understand what is the image? Yes or no? Okay. So you cannot directly insert the image to your system. You read that image. Python having some code to read image. Like we will discuss in there, different library functions are there. You can use that. For the ignore, it will be helpful. Those are moved to the image. Because image itself, it is a complex term. First you understand the image. Clear? Now comes to the what is the importance? As I said, medical image analysis is very important. I'll give one idea that suppose in your exam, first you read the question, immediately you are able to write the answer? No. तुम्हारे parents क्या बोलते हैं? Read the question properly, at least 2-3 times. You know the answer, but which answer in which way you explain? मैं तुम्हें बेटी को बोलती हूँ कि you read the question 2-3 times after that you start writing. Clear? That means what? At that time, your memory will analyze the question in the single part. So this is the analysis. So image analysis is very important in medical diagnosis. Clear? So here I'm written here. It helps in what? Early detection. Why image analysis is required? Because it is helpful for early detection, treatment planning, and monitoring of disease. If you identify your problem, then you can plan. Suppose you find out the tumor in your brain. That means what? You have to plan. Within 2 months, 3 months, or whatever, you have to make a surgery. Yes or no? So you have to plan accordingly. You have to find out the problem in its early stage. If your cancer is in last stage, it cannot be curable. If it is identified in its early stage, it can be curable. So it will be helpful. So medical analysis, image analysis is really important. So image analysis, automated tasks like tumor detection and segmentation, disease classification. Overall, we can identify the problem and find out the problem in which location exactly it is arising. Suppose in your MRI image, having so many parts, so many pixels, but in which location the tumor is present? Suppose doctor cannot find it easily. Take the help of AI. Take the help of the software. That means what? Find out the particular location. How do we find out? Find out the using the segmentation. That means separate out the whole image into number of segments. Suppose I am saying the BC student registration number 1. I am calling at the gate. Can he or she respond over me? No. If I am saying the particular student whose registration number is 1 and placed in the specific building in that floor and the room number, he or she can easily respond to me. Yes or no? So if I am identifying the problem in the specific area, that can be, it is easily curable. नहीं तो क्या होगा? You can find out the tumor in one location, you will take the surgery in another location. Obviously, patient will die. So, segmentation is very important task. The second task is what? Classification. The tumor in which phase? 1, 2, 3 or last stage, whatever. So, classification must be required in the next step. Next is the key benefit. Progress of monitor means sequence of image after 15 days, after 20 days, after 1 month. This is the progress of the tumor. This is the sequence of image. Next is this is the overall whatever I have written in the PPT, that is the tabular representation, easily you can identify. So here binary, all of you go from binary, they can form a multi-spectral image. So where this is the description, it is clearly written. Any doubt ask me, because already I have explained about the image, terrestrial image, then RGB image, multi-spectral image. It is the high or 3D 4D image. That means image size is high or in the high form. So you cannot use that one in your current lab or in your laptop. You cannot use that one. So for that you are using the high performance computing lab. Okay. Next is the overview of medical imaging modalities. All of you know what are the modalities or the techniques. Modalities means what is the medical term modalities. So what are the techniques? Here the X-ray imaging, computed tomography imaging, then magnetic resonance imaging, then ultrasound. So out of these, initially suppose you feel pain in your teeth. So you conduct which type modality? X-ray. Suppose you fell on the floor, you feel pain in your leg. Which is the first phase? X-ray image. Yes or no? Then suppose you feel pain in your head for longer period of time. Doctor suggests for what? CT scan. Suppose you fell in a road accident. Doctor suggests for what? CT scan. But if you never found any problem, but still you feel pain in your head, that means what? The doctor can suggest for what? Detailed description about your disease. Suppose you take the MRI, detailed description where exactly that problem arises or not. So detailed description. All of you know the ultrasound, this is the high frequency sound with real time ultrasound. Take the image of your belly. So this is the ultrasound instrument inside the belly. That is the ultrasound. Okay. So these are the different modalities or the imaging technique. So it is clearly written, that is the overall description. You can easily find out all the difference among these modalities. So which one is the more painful? Can you analyze? Which one is the more painful? Best for what? These are the features. Features means what? What is the features? What are the features? You are the student. What are generally from the database or the database point of view? These are the attributes. But for the medical law, it is the features. So what is your attributes? You are the student. And what are the attributes or what are the features? Student name, student registration number, then your address, mobile number. So these are the attributes. So here each modality having some features. So this is the features. Technology. Which type of technology? Then image is which type? This is 2D image. X-ray. As I said, it is a 2D image. But CT scan it is a 3D image. And it is far high detail awesome image, and it is a real time movie. Then which one is the more cheap, more costly? More costly. This one. More expensive. Okay. So this is more expensive. Then this is cheapest. And maybe we will take 200, 300 products. So here advantage is what? Advantage, to take the advantage of each modalities. This is the fast, cheap, widely available. Every center or every medical more time, 20 to 60 minutes. So it is a time consuming task. So every modality is having some advantage and disadvantage. Then you just tell me, just to conclude, which one is the best? Can you say which one is the best? No. According to your problem, you can identify or the doctor can suggest that technique or that modality. That imagine technique. Go through for that. Yes or no? So this is the challenges in medical imaging. You take the image. Why you prefer to the digital image? Why use the digital image? You take the selfie. तुम लोग सेल्फी लेते हो कि नहीं? जैसे मेरा फोटो बहुत सुंदर आएगा, हाँ? So you choose which one? अरे तेरे पास तो बहुत अच्छे पिक्चर्स है, तेरा देख फोटो. That means what? You take your image, you look better than your friend. That is our objective. Each and every person having that objective. Yes, सुंदर आए पास. That means what? Behind that having some technology, nothing than that. So here, noise and variability. Suppose you take the image. Noise means what? Unwanted thing in your image. Unwanted thing. That means that is not required at the time of diagnosis. Clear? Noise means unwanted thing in your image or unwanted object in your image. Have you seen the MRI image? Suppose written L or something tag is there 001. That means what? It is an unwanted thing. So this is the one type of image. Another thing, suppose poor position of the patient. You can take the image at the time the patient can move here and there. Radiologist suggest what? Sit properly or stand properly. But at that time you just move here and there. That means noise is there. Another is malfunctioning of your equipment. If any problem in your technology or in your machine, that is another type of image. So before taking any image, you make sure all the things are properly placed or not. Yes or no? जब तुम लोग जाते हो एक्सरे के लिए, they put some different way, different garment देते हैं कि नहीं? Yes or no? That means what? You take the image properly. So here, noise means what? It is in a different form. Different form means we can say Gaussian noise, then MRI, Gaussian noise, then MRI, then technique in ultrasound, then variability. Variability, as you said, that means the distance between the machine and the patient. Suppose the patient can move here and there, or the hardware inconsistency, as I said, malfunctioning of the equipment. Then scanning protocols or angles. Suppose your angle is this side, but in the next moment you can move to the another side. Angle is very, very important. Radiologist will you can sit or stand over in the proper position, but in between you just move your or change your location. This is the angle. Yeah. So this is very, very important. Normal inherent variation in individual body structure such as difference in size, shape, location, or the presence or absence of features. So impact is what? Reduce the ability of automated analysis and voice generation. Obviously, if you found that noise in your image, you cannot identify the problem or the disease in your MRI. So clarity must be needed over there. Clear? Next is the high dimension. Already I discussed. It will better to convert your image in 2D image. First, already discussed from the time complexity, from the space complexity. So it will better to use the 2D. Then data privacy and size. What about this? Privacy means what? You cannot access the patient data. For that, you have to take the permission. Because when I did my PhD at 2013-14, I take the permission from that Medical Image Analysis Society, MIS Society. They provide some key for 48 hours. They provide some key. After that, they will provide some key for only for 48 hours. After that, it will disable. That means we cannot download that image. And for that, downloading that image, I need, I see, for more than 40 hours, more than that. We need more than that time for downloading this. But image size is very large. Okay, so if your image size is large, that means what? It will take more space. Suppose you save your image 40, 30 or whatever the image. What you save one video? Which one takes more space? So yes, the video will take more space in your memory, computer memory. So here data privacy and size. And another thing here, all of you point out DICOM. DICOM क्या है? DICOM image. Digital Imaging and Communication in Medicine. This is the database where we can store our image, we can access our image, we can transfer or transmit our image to the other location. This is a platform. Another the higher hospital or larger hospital, they can store the image, patient image in the DICOM form. Clear? Suppose in a small organization, maintain the database? No. Manually they can provide the information to the student. Suppose in library management system. You take the issues of books from the library, put your signature, this is the issues date, this is the due date, within 3 months you can submit your, but otherwise you will give some file will be there. If not, suppose only 4,000-5,000 students are there. But think about the organization having more than 20,000-30,000 students. So is it possible? No. For that, having a software, library information management system, implement over there. That is costly. But for handling the huge data, we need the database. Plan for that. So here, DICOM is the digital imaging and communication in medicine. Specifically, files are large and scope intensive, especially in longitudinal or multi-patient studies. It's a standard for handling, storing, printing, and transmitting information in medical imaging. This is the standard form. जैसे कि तुम लोग branded garments use करते ना, so this is the brand. So here, this is the what? This is the specific brand, or you can store the image in that DICOM format, so easily you can accessible or transfer that file. So in fact, this limits data training, model training, and scalability across implementations. Next is fundamentals of image processing, image size and format, key steps in image processing, tools for image processing. So all of you know grayscale image. Already I have discussed grayscale image, RGB image. So this is the range of what? It is written. This is the zero represent the no contribution of that color. For example, your black. For that channel 255 represent the full intensity, maximum brightness of that color. So this is the 0 to 255. If it is color image, then 256, 1 to 256, 0 to 255, 1 to 256, whole to the power 3, because it is a channel-stick RGB. So channel-stick power. This is the pixel value. Then DICOM image. Already I have discussed DICOM image. Then image acquisition. So first is in image processing, the first step is image acquisition. Image acquisition means what? Take the image. This is the acquisition of the image. You will take the image properly. Obviously, it is in clean form. If not, that means the noise are there. Clear? So this is very important. The quality of acquired image heavily depends on equipment setting, patient motion, operator expertise. Expertise must be included. तुम लोग एक्सरे करते हो कहाँ पे? Having some specific department जहाँ पे जाके करते हो कि नहीं? या कहीं भी करते हो? No. So having some trained person over there, take the image. So noise in your image. So obtain clear standardized image for downstream analysis. If your image is clear, that means you can easily identify your problem. Identify your problem means what? You can easily identify the disease in your image. Then comes to the pre-processing. Actually, in pre-processing, I have some paper. That means these are the techniques. Later we discuss the one paper already I published regarding this point. Different type of noise. These are the medical noise reduction denoising. Types of noise: Gaussian noise, spectral noise, Poisson noise. These are present in this image modality. So here, what are the techniques? Noise is commonly reduced the pre-processing stage. So we are using the filtering technique for that. Then why we use the filter? तुम लोग घर में filter use करते हो कि नहीं? या कौन से use करते हो? Basically that is the filter. Clean water. Objective is what? Clean water. Yes or no? So here is also to remove the noise, we are using the filtering technique. So in which case we are using the filtering? In pre-processing stage. So here, this is the inner filter. Inner filter क्या है? Preserve edge and fine detail. Preserve edge. Edge मतलब क्या है? Boundary. Suppose you identify the tumor in rectangle or in oval or in a star-like structure. So this is the edge. New research or new image because to preserve that. Pixels take the weighted average. That means all the pixel value divided by 4. So this is the average of that one. So in the next step, you take the average value of that polygon. Suppose you are taking the 6 neighboring pixels value. That means add this value. Value means intensity of that pixel and divide by 6. So accordingly, you have to use the Gaussian filter. Median filters means what? Replace each pixel with the median neighbor pixel effective for salt and pepper noise. You remember what is the salt and pepper noise? Salt and pepper means what? Salt means white. Pepper means black. So black and white. So this is the one type of noise that is placed inside your image. So you are using different filtering technique to remove the noise. So tools is what? Remember you are using the tools. For removing or using this, having some facilities in Python. So you are using the Gaussian block. That is the function in OpenCV. Have you know idea about the OpenCV? OpenCV is specifically used for the object detection. Suppose I am standing over here. Light है ना अभी सारा light में है ना. Suppose I am put down my eyes down. This is the position. If I put down some downward, that means what? It will detect immediately. The person is in drowsy. If I close my eye, for that there is some algorithm. OpenCV provided. It is in the Python library. It is our library file that is inbuilt in the Python. Okay. So for that we are using the small font code I will discuss later. No more than that. So then these are the type of noise and what are the cause? It is clearly written sources of noise in medical image. Then imaging modality, type of noise. Whatever I have discussed, that is written in the tabular form. Easily you can analyze it. Okay. Clear? Or any doubt? Any doubt? Okay. So this is the intensity normalization. What is normalization? MC student में नहीं यहाँ पे. Again accordingly. Suppose normalization. Why we need normalization technique? Suppose in an organization, one person, all are into teaching, non-teaching, all are employed in an organization. Suppose a person whose salary is more than 1 lakh, but another person whose salary is 5,000. How we can normalize it? So whatever the salary is an attribute. In this expression or in this question, salary is an attribute. We can normalize it. That means whatever the value, we have to put in 0 to 1. Jitna bhi salary ho, you can put in the 0 and 1 for what? For easy calculation. Before moving to any information to your model, you have to analyze your data. That's why we need the normalization technique. Getting my point? All of you understood why we normalize? So, in your data set, if you found any data, ask to normalize your data. For that, having different normalization techniques. Mean max normalization, Z-score normalization, different normalization techniques are there. Then you just think how we normalize it, having some formula for that. But Python provides some function also. Mean max also having some function. You just put your function inside the bracket, that means you pass your parameter, that is your file. Whatever the file, how many row and columns are there, it will be normalized into 0 to 1. You just check. Suppose for experiment basis, you take one Excel file in your class. Student 50, 5 subjects. How many row, how many columns? 5 subject means 5 columns. 50 student means number of records. Getting my point? That means what? Your Excel file, 50 row, 5 column. Getting my point? So you collect the information from your 5 subjects. Student 1, these are the 5 subject marks. Student 2, these are the 5 subject marks. You just put the file, import that file, CSV file or Excel file, and read that in your Python code. That means it will normalize. Whatever the value, jitna bhi value, 50, 60, 90% in your each subject, it put that value in the 0. Okay? So that we have to normalize. So normalization is very, very important. In your image, some value contain 0, some value contain 200, some 5, some 150. Then normalization must be needed at that time. Okay? So these are the techniques we are using the normalization. Then contrast enhancement. Contrast तुम लोग कैसे करते हो मोबाइल में कंप्यूटर में कैसे करते हो? जैसे कि लाइट थोड़ा हाई आता है, लो आता है, that is what contrast, visibility of clearance of your screens. Yes or no? In your mobile or in your system. So here also you guys having some contrast enhancement technique. That already I have implemented this technique in my paper. Later we will discuss. So here histogram equalization. Take the HE function. You take the function in your Python, put your image in that. It improves the image intensity value. Clear? Histogram equalization. How it will work? Python provides the function, but behind that there is some algorithm. It will better fast you understand your algorithm. After that you use the code. So here you are using the histogram equalization to improve the image quality. Suppose your image is not clearly visible. That means what? You are using the histogram equalization technique for that. So next is the click. Means contrast limited adaptive histogram equalization. Also provide some function. I can provide some function. But before that you are using the algorithm. So you analyze or explore the algorithm. Any image, you take that image and put that image pass as a parameter. That image pass as a parameter to your function, and it will display. That means before using click, after using click, you feel the difference. Okay. Suppose in your semester, first semester you prepare 2 to 4 test, and your score is 70.5 or 80%. But if it is so less, then go for hard work. That means you spend 5 or 7 hours per day and your score is more than 90%. That means what? You put your effort on day basis. So here is also you improve the image quality by using some algorithm. Have to understand the algorithm, how it will work. After that, use the Python. So Python provides some function for that histogram operation. Then, so while resizing your image, suppose as I said in my during my research, my image size was row is 1024 and column is 1024 pixels. I have resized it into 255 into 255. Why? For easy computations. For easy calculation, we are resizing. Sorry. Why we resize our image? For easy calculation or easy computation. So here, common interpolation methods are used. So many techniques are used. But thing is first, if I resize our medical image, you just test it whether information lost or not. That is very important. Suppose I am resizing my image, it will lost my information or preserve as it is. So for that, you check some metrics by using some parameters over here. So these are the parameters. Peak signal to noise ratio, then structural similarity index, then mean square error, then feature similarity index, then X determination matrix. Already I have done some paper based on three things. These three things, PSNR and SSIM and mean square. It will be better to check all the matrices or all the parameters in your image. Okay. Suppose you resize your image, someone asking you whether the information is preserved means as it is or lost. Then you just apply the technique. That means before resizing and after resizing, you check the parameter by using these methods. If it is okay, that means only 1 or 2 point little bit difference over there, it's okay. If you found the much more difference, that means information lost over there. So think about that, another technique. Clear? So you just test that image by using the matrix or using these parameters. Then these are the matrices, quantitative assessment method. Next come to the cropping and padding. Cropping means what? Image को crop करना. Image को crop करना. इसका छोटा करना. छोटा. Suppose you are focusing the specific area, region of interest. That means where exactly the tumor found. So you use the ROI. Ensure the uniform shape. That means cropping, remove irrelevant background. Suppose you find one tag in your image, medical image, X-ray image or MRI image. You just crop it. That means remove that tag. Suppose written 001 or any A or R part written, suppose the specific patient left side part or right side part, if it is found. That means you crop that. It is not required. And another is the zero padding. It is very, very important. Generally, it is used in convolutional neural network. Padding is very, very important. First, add before to standardize. तुम लोग घर में क्यों बाउंड्री करते हो? डॉक्टर है बाउंड्री क्यों है? ठीक है why you are having put some boundary in your surrounding? Security and for the security, only for the security or privacy. The outsider cannot move immediately. Take some step. Yes or no? Take some step. Yes or no? So now we are using the zero padding in your image processing. How? I'll give one problem for that. Zero padding. Regarding zero padding, those are holding mobile iMacs. Zero padding. Tell me. Session should be interactive. Session if you may explain clearly, you see that. No. One problem is there. I have explained clearly. I'll give 1 minute, all of you analyze it, and I will ask you just explain it. Zero padding. Already given the real life example. Just to make sure this is the example for the image.
Zero padding means there is no border in the image.
Context? Zero?
Zero padding means there is no border in the image. Border means the chart states in the image, the chart states border in the zero padding.
Why it is the zero padding? To preserve the information. This is the safety mode. Why you are using the ATM card in your pocket? तुम्हारे पास तो 500, 1,000 है अभी. तो student, why are you using the ATM card inside your pocket? तुम लोग नेट बैंकिंग यूज करते हो ऐसे मत करो. Just you are the student. The student point of view. Why you are using the ATM card? Huh? Emergency. So here your medical data or image data, it is very sensitive. Suppose you found a tumor in one location, you just discard that one, copy that one. Then how the doctor can identify that one? This is the difficult task. So it will better to put a set. That means are the previously that was what? This one. 3 image is what? 0, 3 comma. These are the pixel value. ये जो image का है ना, these are the pixel value in the image. And after we apply the zero padding of size 1. Size 1 means only one row you have to add in each side. Left, right, top, bottom. So these are the size 1. You can add 2, 3. But it is written zero padding of size 1. Size 1 means left, right, top, bottom. One row you have to add that value is 0. Here कितना हुआ? How much? 5 row and 5 column. Getting my point? So in CNN, it will better to use the padding to preserve the information in your image. Yes or no? So this is the zero padding. Already I have discussed the pre-processing technique. Then image segmentation. Image segmentation means what? To find out the particular location where exactly problem arises. Problem is suppose tumor is present. That means in which location? Pixel value, according to pixel value, suppose this is the building. In which location? Can I explain? This is the building. No. Which row, which column, that means which building, which room number, which floor. After that, you can move to that room. Otherwise, it is not possible. So here, you can object. So here you are using the region of interest. And it was usually want to analyze or segment or classify. Why you focus to the segment or why you focus to the region of interest? Region of interest in any image, 0 means black. 5 means intensity value is high. 255 you will found any pixel value 255. That means it is larger. That means it is high. Intensity value is high. That means the ray cannot pass to that cell. Number 10. In that cell the ray cannot be passed. So that location will be suffer or intensity value is high. More white. You can visible that is the cell in white. So this is the tumor part. So here it is written egg detection, then vision growing. Generally we are using the ROI. One algorithm is there. Region of interest. Suppose here I am using the thresholding value. Threshold means what? Intensity value is high. So just discard the value below 100. Suppose you found any pixel value below 100, you discard that. That means you put the threshold value, the value above greater than equal to 100. That means what? Your output will be what? Only the pixel value that is visible to you, that value should be larger than 100, equal to or larger than 100. This is the concept of ROI, region of interest. Region of interest means by using the thresholding technique. That is the one technique, thresholding technique. Clear? Suppose in my class, I am supposing the student whose score is more than 90%. Just forget about below the 60 or 50%. That means what? Our objective is what? To focus the student score more than 90%. If I found 2, 3, 5, whatever the number of students present in my class, that means I am supposed to them. चलो मैं ऐसा नहीं करती. This is the example. Don't take anything. This is the example. But is you not interest? Okay. Suppose if you are planning to move any area in our country, that means region of interest. क्या करते हो तुम? उसका climate, then visiting location or place, then temperature, everything we have to search for. After that, you plan to move over there. And best timing for visiting over there. Yes or no? This is the planning before moving or before going to that place. So here, region of interest means in which location the pixel value is high. Tumor means pixel value is high. That means the ray cannot pass to the pixel. Please written whatever that is written in the regular form. It is another step. Step 4, picture extraction. All are in the pre-processing. Remember, all are in pre-processing. This is the picture extraction. Suppose I am giving one example in database. Because all of you know what is database. Yes or no? You are the student. You are the student. And what are the attributes? Your name, registration number, then mobile number, address, whatever. Which one is the primary key? Think about this. Your registration number, you cannot delete. You cannot leave that information in your database. Otherwise, inconsistencies should be there. Okay. So here, your feature is very important. So image का होता है ना, that is the features. Is very important. So you extract the feature. You extract the feature. That means what? From that image, suppose 20, 30 features are there. But which one is the important? You extract that features and that information provide to your model. This is the feature extraction. Suppose in your student database, 30, 40 number of features are there. But I will only include that your registration number and remaining 2-3 fields. That is very important for us. Okay, for accessing the accurate information from the database. So here, feature extraction is very important. For that study, different features are there. Already we did one paper for that. Only based on that. Texture feature. Texture means what? Contrast, correlation, energy, and homogeneity. So how you can extract these features from your image? By using the algorithm. By using the algorithm GIET, Gray Label Co-occurrences Matrix. Has to understand the algorithm. After that, you use the function. सारा function है available है. But it's my suggestion. Has to analyze the algorithm. कैसे होता है? Step by step procedure. After that, you use the function. Next is the set features. In set features, what are the features we have to extract? Area, perimeter, circularity, then intensity features, mean, standard deviation, skewness, entropy. So these are the features available in your image. So you are using which technique? You just explain accordingly. कौन सा technique तुम लोग use करो? So these are the techniques and these are the features extracted by using this technique. So you analyze your image, which type of image it is. After that you apply the technique. Which one is the good? Then texture feature is very important. Basically medical image analysis. Then these are the texture features. These are the familiar techniques we are using, and everything having some formula. GSM, then LVP, local binary pattern, then robot filters. These are the techniques used for texture and edge features for specific image. Suppose your fingerprint. Suppose you identify the blood group. Already I have given one paper based on that. Your fingerprint. How many steps are there? Have you seen your fingerprint? Circular, then what? Ellipse, then something triangle like. You found some different steps. Then how you can preserve? A black is black, then white. That means what? You preserve the edge. So in that case, this algorithm is very important. Local binary pattern or Google filter. Already I have applied the Google filter to extract the texture edge features specifically. So these are the techniques we are using for image for extracting the features. Feature extraction is the important task. Then comes to the this is the tabular form whatever I have explained that is written over here. Then GSCM, just you read the GSM. Any doubt? That means this is the calculation. This is the some mathematical calculation is there for each feature. That means here contrast. How I calculate the contrast of your image. This is the part it measures. That means some mathematical part is there. If you follow some papers, it is clearly written and use that mathematical part or for any computational means function. For each having some Python function, you can use that one and extract that feature. Then correlation. Then how correlated a pixel is with its neighbor over the whole image. That means so here it is what homogeneity, entropy, dissimilarity. So it is clearly written. Next is what step to use the GSM. So I will always suggest that you use the GSM feature. That means gray level coordinates matrix. Here, it will better to use that one for your image. Here, how do you have what are the steps for GSM? I'll explain only this one. Try to implement this one in your image. Clear? It will better to implement this one This is the GSM code. I'll explain this one. It will better for you to implement this one. Listen. Import NumPy as NP. NumPy is a library that is available in your iPhone. That is freely available in Anaconda. Just all of you install the Anaconda and import the NumPy as NP. Clear? Import matplotlib, pyplot and PLT. That means this is the file, library file for display the output, graphical method. Suppose you want to display the graph, so that you are using the matplotlib. Then SQL image import the colors. That means read your image for you to use the library. Then read and convert the image to grayscale. If your image is in grayscale, then simply read that image. If not, then convert into grayscale. This is the step. This is the image.png. So it is the color image convert into io.imageRead. This is the function. Okay, imageRead. Where it is available? ये जो है ना यहाँ पे ये लाइब्रेरी फाइल में ही अवेलेबल है. So you have to io.imageRead example image.png. Whatever the image that you have to store in the single quotation. So load the image, then convert into grayscale. See, RGB to gray, that is the function. You put the image. This image कहाँ से आया? This is the image. The value stored over here, and that information passed over here. That means this image now convert to grayscale. हो गया कि नहीं हो? So now grayscale image. Then move to the 255. 255 you need 8 bits. 8-bit image. You convert your image into 8 bits. That is grayscale. 2 to the power is how much? 0 to 255. This is the 8-bit image. Then compute GIET. This is the computation. How you compute? This is the NP. NP into 5. 180 divided by 4. How much? कितना हुआ? हाँ? This is first is 0. Then 5 divided by 4. कैसे होगा? 45. 45. Then n by 5 divided by 2. That is how much? 90. Then NP into 5 divided by 4 into 3. How much? 135 degree. So how you calculate? This is the calculation. This is the symmetry calculation. Then extract the features. These are the steps. These are the steps. Then extract the features. What? Grade CO, PS. This is the function. You have to use the function and extract the contrast of your features. How many features are there? GSM. These are the 4 features already I discussed. Contrast, coordination, energy, homogeneity. You put that value and extract and store over there. After that part, once the value is stored in the variable, you will display that part. Now comes to the last part. This is the display the result. How will be displayed? By print. This is the GSM text features. Because whatever written, that is text, some text, expression, more text. That means syntax is always converted into string. So that's why it is a contrast. This is the new line. This is the value stored over here. Generally, Python में क्या होता है? Everything you will store in the string. So you need print inside the bracket f. Why it is written f? Because whatever the value stored in the contrast variable, that is converted into string. Clear? That's why we need a. Otherwise, it cannot be displayed. Getting my point? Integer में कुछ भी value नहीं लेता है. So you have to convert into string. So a contrast, whatever written in double quotation, that will display to the user. Getting my point? Whatever written in a double quotation, that is displayed to the user. So these are the GSM feature extraction technique. This is the algorithm. How the algorithm implement in your image. Then, so some reading image in various formats like PMG, JPG, all of you know different form of image. So here this is the import image IO dot G2 HIIO. In this way, you have to import your image. So import matplotlib, iplot as PLT as I discussed. So next is the image. Then OpenCV, open source computer vision library, is one of the most popular tools for real-time computer vision. Then how you can import that one? By using the cv2.imread. These are the different ways you can import your image in Python. Okay? So this is the another way you show your image. Another is the matplotlib. You are using multi-platform data visualization. This is specifically used for the data visualization. Whatever the information you want to show in the practical manner, matplotlib is very, very important. Then how you can use? You cannot directly use the function. For that, you have to import the library first. जहाँ पे है, so you have to import that library. जैसे कि C में करते हो ना, हाँ सिंपल. stdio.h, printf, scanf functions are there. So here you have to import a matplotlib.image as empty. So here using the PIL, this is the new one. PIL is a Python enabling library which provides a Python interpreter with image editing capabilities. You can edit your image. That facility is there. So from PIL import image, then image open, then show image. These are the library file that is available in your Python. Okay. So now comes to the already I have discussed these things. Now comes to the machine learning. All of you, I think I have some idea about the AI, machine learning, and deep learning. Overall, I am saying this is the circle, outer side, that is whole thing belongs to AI. Okay? Whole thing belongs to AI. But now we move some deep, that means specific area, that is the machine learning. And more deeper, that is the deep learning. Overall, I am saying in the field of machine learning, in specifically medical image analysis, you extract the features of an image by using some algorithms like your Google filter, like your GSM metrics. But in deep learning, you just feed your image, it automatically extract the features from the image. This is the one type of black box. Also important, it will not provide the detailed information. So it is a deep learning is one type of black box. So first of all, it is better to move machine learning. After that, you use the deep learning, and you feel the difference. Like in your class, suppose a student score more than 90%, another person score 60%. That means that what? The difference between the percentages. After that, I am asking, she is best student, she is average student. Yes or no? So here you find the difference. Similar technique. Now we discuss the research paper. Overall things already I have discussed. Now comes to the research paper. A comparative analysis on different techniques used in pre-processing of mammogram image that was published in 2020. So basically, that this paper focused on the my research is mammogram image. So find out the tumor inside the breast image, that is the mammogram image. So first is what are the outlines? That means to find out the cancer, breast cancer in its early stage. That means our objective is what? To find out the cancer if in early stage, then it can be cured. So it is a mammogram image. So techniques are there. So here it is the survey, I don't know, survey in India during 2016 to 20, and this is the BRCA1 and BRCA2. These are the two genes specifically used for the breast tumor detection. That means specifically these two are responsible for find out the cancer or for the cancer. So next is what? To find out the image potential. Image potential advantage of digital mammography are image processing capability, then possibility of computer-aided detection method, and because if you're doing any research, it will better to focus the recent literature. So here I am focusing the different literature at that time. Now this is the materials and method. As I said, you cannot access the patient data if it has some rule and regulation. So during my research, I have downloaded the data, mammogram image analysis society, and overall that image there is 322 image and 63 benign, 81 malignant, and 208 normal. The size of both the image 1024 row and 1024 column. Clear? Clear? So next is before doing any research, you have to plan some model. Model is very important. But overall representation of your project, of your research. So this is the whole task prepared over here. That is, this is the computer aided diagnosis system used for identification of masses in the brain. First is the digital mammogram. The mammogram pre-processing, apply some segmentation, then feature extraction, classification, evaluation. This is the overall task during my PhD. These are the overall tasks. But first is what? Pre-processing. Pre-processing step is very important. So here I collect the data from the millions data set and resize it. That means using some technique, resize it and check whether any information lost or not. Whatever the technique already I have discussed. And apply some noise. Noise means what? Salt and pepper noise, Gaussian noise, and apply some noise by using the value 0.2, 0.3, 0.4 to test that image in which value it will give the better. Then filter and filtered image. Whatever the filtered image over here, that means now it is ready for segmentation. Means what? For feature extraction. So here I am using the experimental result of median filter, winner filter, then mean filter, Laplacian filter, and what are the output here. So this is the PSNR, peak signal to noise ratio. How we measure the performance of a student? How we measure the performance of a student? How we measure the performance of a student? Huh? How we measure the performance of a student? What are the parameters? Result means what? What is the performance measure parameters? Close to the answer. Next. Percentage. Your percentage. So here we measure the performance of a image by using the peak signal to noise ratio and mean square error. It is both are inversely proportional to each other. If the image quality is high, that means obviously the error is less. If error is more, that means image quality is less. Clear? So these are the performance measure parameters. So here we are using the different mean square error. This table is specifically for what? PSNR value and this for mean square error. You have to calculate this one. And what you conclude from the conclusion? What you conclude? Both the winner filter and median filter provide better PSNR and less mean square error value. The mammogram with poison noise. And from the above study, conclude that no one filter is will operate on all types of study. Key contribution, that is implementation and evaluation of two different metrology classifiers to determine the most effective model. How to compare? Comparison is very, very important in your research. You cannot say your work is better. You first compare your work to your previous work. Okay, next is comparative analysis of model performance across different broad groups using standard evaluation metrics. You measure the performance by using the different metrics. By bridging the gap between biometrics and medical diagnostic, the proposed system for using for practical scalable applications is more both healthcare and identity verification. Yes or no? Then problem statement. This is the overall one. This is the model. Model is the graphical representation of your whole work. So here I have taken the raw data. Raw data, that image size is 120 is row and 120 is column. How many classes? 8 classes. It is a multi-class classification problem. Multi-class means more than 2. Okay. So here, this is the 8 class classification problem. How many problems are there? How many problems? 8? Yes or no? How many problems? So here, pre-processing technique. What are the pre-processing? First, we apply the pre-processing technique in my data set. That is the clay, Gaussian blot, adaptive thresholding. Yes or no? So these are the techniques we have to apply the pre-processing phase. Next is the segregate the data into training and testing. Training and testing means when you provide your model or feed the sample to your model, first you train your model. How? What is training and testing? In our day-to-day life, suppose you appear exam. After 40 or 50 lectures, you appear the exam 40 hours. So 40 or 50 classes already you have appeared. So this is the training phase. So when you train your model, so first of all you divide your whole data 70%, 30% or 80%, 20%. After that you feed that information or train your model by using the data and remaining samples are used for testing the data. Clear? So you appear the exam only for 3 hours. From that you can find out the percentage or what are the performance of my student. But during the 40 or 15 hours classes, this is the training phase. Only I give the lecture to my student. Only give the feedback or input to my student. After that, I will appear the exam. So training phase means 70% data. That means more data. Suppose 1000. That means from the 1000, 70% provide for training is epoch? It is the training time required. Suppose you are the MCA student, how much time needed for complete one rotation means complete your master degree? 2 years. This is the what? Duration of your course. So here epoch is the total time required to train a model. Suppose epoch is 3000, sample size is 3000. If I am defining the base size 500, then how much epoch needed for that? How much iteration needed for that? 3000 divided by 500. 6. That means number of iteration is 6. That means 1 epoch it is 6 iteration. One complete rotation it will need 6 iterations. So similarly, here I am using 300 epoch. 300 times it will train. 300 epoch. Each epoch it will take 6 iterations. And 300 epoch it will take how much iteration into 6? Okay. So here this is the epoch. Epoch means just remember it is the total time required to train a model by taking its whole sample. 70%, 80%, whatever the sample it will take the total training time. That is the one epoch. So this is the most probably this question asked by the most of the reviewer or most of the outsiders that ask the question what is the epoch. Then CN accuracy that is the appliance of pre-processing technique. Before pre-processing, after pre-processing. But the value nearly equal in 100 epoch. But here the value 300 in 300 epoch. If we apply the pre-processing technique, the value should be provided within 100 epoch. That means that it will take less time in comparison to this one. If we apply the pre-processing technique. Clear? Now comes to the loss function. Similarly, here it is a graphical representation. Here CNN epoch 300. This is the general CNN. That means base model of CNN. After that we are using the improved CNN. That means apply the clay, Gaussian law, epoch 100. So it is nearly equal to same. So what do you conclude? The standard CNN model trained for more epoch 300 to slightly better performance in terms of accuracy, equal and efficiency. So both models get the same result. So what you conclude? If we apply the pre-processing technique, it will take less time and provide a better accuracy in comparison to our base model that are using only the simple image or the raw image. So this is the conclusion. Then these are some references, and these are the future directions. We also want to do some research. These are the future enhancement. That means advanced image processing and machine learning and deep learning. Then different options are there in deep learning. Then together they enable faster, more accurate, and more personalized medical administration and treatment planning. So these are the future work, and key challenges remaining in data availability. Obviously, the data is very sensitive, so it will be very difficult to take the data. So during my research, I have collected the data. It will be already I have taken the 1 year for collecting the data. So model interpretability, domain generalization, and ethical considerations. Then the path forward require collaboration between AI researchers, clinicians, and regulatory bodies to ensure safe and effective clinical use. So that is a very, very important. So we cannot do the research ideally. So clinicians must be involved over there. Okay. So these are the overall conclusions. These are some key references, and there are some key references over there. And I have gone through the different advanced techniques. That is the 2025 current version, and this is the major features. And these are the so many advanced papers I have followed during my presentation, or I prepared my slide based on these papers and some key challenges. This is my ask questions and I will screenshots and I will answer. So all of you prepare for ask questions. Clear the questions and enhance my ability, improve my performance. So that is my thinking. So always I welcome the questions from my students.
Thank you, ma'am, for this amazing presentation. Now I request Professor Bhubaneswar